AI has become the most talked and hyped topic in recent years. I am sure in one form or another you also already use it. You may have also an understanding of it, or at least you think you do. But do you really know how AI works? How an AI model is created? This is Black Screen. Today we will debunk AI and make it clear like black and white. By the end of this video you will able to understand AI on very low level, and you will able to explain it yourself also instead of just accepting it as a black box. In order to understand artificial intelligence, let's first have a common understanding of intelligence. So, what is intelligence? To answer this question, we will use an analogy of a child being able to recognize an apple. How this works? A child sees and tastes for the first time an apple and it is told what it is. This may repeat couple of times depending on the age and other factors. At some point the child saves and can recall this information when it sees a different apple. In other words, it learns to recognize an apple. To keep things simple, let's say intelligence is a stepwise process of learning, adapting, reasoning, and providing a solution. One uses the information from past experience to adapt in a new situation and tries to come up with a solution that is based on some reasoning. When you put these abilities in a computer machine successfully, that machine becomes artificially intelligent. And that is AI on a very basic level. So, now that we know what we mean by AI, let's talk about how we could achieve this. If we stay with our child recognizing a fruit analogy, then we could propose the following model or methodology. We could try to mimic the process of that analogy such that we achieve at the end the same results. We will show a computer different kinds of apples which will be saved in its memory. And at some point when it sees a new one, it should be able to recall that information and recognize it. Since we want to have a general model and not just a solution for recognizing an apple, let's come up with a more abstract and general way in which we will use computer terminologies like data. We will divide the process into 3 phases: data collection, learning, or also called training, and the usage. The first phase is all about finding and fine-tuning the correct data for our machine. In our example, this would be pictures of various types of apples. If we want our machine to also be able to recognize other things, then we will need images of those things too. In second phase, we will train our machine with data from the first phase. For this, we will have to create an algorithm also called AI model. How that is done, I will show in a minute. Actually, we will create some from scratch. After the model has learned from the data and has been trained, it will be tested and validated on its accuracy. The last phase is about the usage of the model. In our example, it would be able to recognize objects. Now till here, everything in our method seems to be quite straightforward, besides one thing, namely the AI algorithm or itself. How can we write an algorithm that can learn from data? In order to answer this question, we will take a step back. We consider this an engineering problem. By definition, engineering is the process of finding an efficient solution to a problem by applying mathematical and scientific methods. So, what is the problem that we want to solve? Well, it is to come up with an algorithm that can learn from given data. At this point, we will take a very short tour of a field of mathematics called statistics. I won't bother you here with knowledge of statistics. Instead, we will take a look at a statistical method called linear regression, and believe me, this will all make sense in a minute. So, what is linear regression? Linear regression is a way to model the relationship between 2 variables by fitting a linear equation to observed data. One variable is considered to be an explanatory variable and the other is considered to be a dependent variable. For example, you could use linear regression to understand whether there's a relationship between the number of hours studied and the score on a test. The line of best fit would show the trend in the data, indicating whether more study hours tend to be associated with higher test scores. It helps us predict the dependent variable of a given explanatory variable based on the pattern we see in the existing data. Too abstract, isn't it? No worries, let's take a look at an example. We will not calculate linear regression manually. Instead, we will use Python and the good work of other people who have already implemented a library for linear regression. If you have a very basic understanding of Python, then you won't have any issues understanding the code. But even if you don't have any programming background at all, you will still understand what is going on. So, without further ado, let's take a look at a simple example. Remember, this video is not about coding. We will just use a very basic program to understand linear regression and to show that it works. First, let's import the needed libraries. Next, I will define both the explanatory and dependent variables. Here we have hours of studying and test results. Now let's create an instance of regression. Then we will calculate the fitting line. And now we can predict the exam score after 9 hours of study. So let's run this program and see the result. As you can see, with the help of linear regression, we were able to predict the score for a given hour of study. And if we look into the code, we can see that the result also makes total sense. This was a simple example of linear regression, but we wanted to create an AI algorithm that could train and learn from data. So how is this helpful? Well, this statistical method has two very important properties. It is calculated on a predefined set of data and it can make predictions. Now, as computer engineers, we can further fine-tune these properties and use them in our algorithm such that it takes input as training data, for example, numbers of study hours and test scores, and then can predict the test score for a given number of study hours. Let's see an example of this too. Okay, let's now run and test our AI model and see the results. As you can see, the model has made predictions for two test values and both are near to the actual value, so they are both quite accurate predictions. And we achieved this by a very small training data. In real-world scenario, of course, that data would be way bigger, and the larger the training data, the better will be the results. Now, that was a simple AI model that we created from scratch by the use of mathematics. This model fulfills all the requirements that we proposed in our approach for achieving artificial intelligence. It can learn from given data and make decisions based on that data. Let's now write another yet simple AI algorithm that is a bit more useful. Let's say we want to have a program that can categorize descriptions into 4 categories: hardware, software, process, and human. Here are some examples of descriptions. So let's try to write an algorithm capable of doing that. First, we import the library that will transform the text into numerical data which our model can understand and process. Next, we use multinomial MB. It stands for multinomial naive Bayes, which is a classification technique. In our model, we have a list of descriptions and corresponding categories. For instance, cost of hardware and license renewal of Office program. We feed this data into our model, which then learns to associate the words in the descriptions with the categories. Once the model is trained, we can input a new description and the model will predict the category it belongs to. And at the end, just a simple logic to be able to run the program multiple times without exiting the program, which is not that relevant to our topic. Okay, now let's test our model if it can get the job done. Here we will give it a description and hit enter. As you can see, our AI algorithm has predicted the correct category. Let's try a couple of more examples. Well, as you see, our model has learned from the description we provided, and it can now categorize new descriptions on its own. Isn't that awesome? And this is called machine learning, a fancy term I am sure you have heard a lot before. Machine learning is used very often as synonym for AI, but actually it is a tool or an approach to achieve the concept of artificial intelligence. It focuses on the development of algorithms and statistical models that enable computers to perform specific tasks without explicit instructions. Instead, these tasks are performed by making predictions or decisions based on data. There are several types of machine learning, including supervised learning, where the model is trained on a labeled dataset, unsupervised learning, where the model finds patterns in an unlabeled dataset, and reinforcement learning, where an agent learns to perform actions based on reward and punishment. I will not dive into these different types. This will be a topic for another video. Artificial intelligence can be classified into three main types based on its capabilities and potential. The first one is called artificial narrow intelligence, also known as weak AI. It is the only type of AI that exists today. It can be trained to perform a single or narrow task, often far faster and better than a human. However, it can't perform outside of its defined task. Examples of narrow AI include Siri, Amazon's Alexa, and IBM Watson. Even OpenAI's ChatGPT falls into this type, at least officially. The second type is artificial general intelligence, also known as strong AI. It is currently a theoretical concept. Strong AI can use previous learnings and skills to accomplish new tasks in a different context without the need for human beings to train the underlying models. This ability allows strong AI to learn and perform any intellectual task that a human being can. The last type is artificial superintelligence. Like artificial general intelligence, it is also strictly theoretical. If ever realized, super AI would think, reason, learn, make judgments, and possess cognitive abilities that surpass those of human beings. This was an effort of mine trying to explain AI and how it can be achieved. Hopefully, it could contribute to your understanding of AI. If that is the case, I would really appreciate if you like, comment, and share this video. If you don't want to miss any of my videos in future, then also hit that subscribe button.